Sounds- Oh, I'm so happy to see so many familiar names here, especially given the short notice of our event and our featured speaker and topic today. So, welcome everybody. Thank you for joining us again for another episode of Science Saturday from the Long Beach Island Foundation. Um, Today we have a really interesting guest. And Dave, you're going to introduce yourself. However, I'm just so grateful that given the last minute invitation, you were able to join us because we often talk about your project or a project that you're heavily involved in, CoCoRaHS, and I'll let you explain what that acronym means during these events. So, for some of the regulars that I see a lot of, you've heard us mention CoCoRaHS as one of the citizen science projects. And for those new here, the citizen science is a way of adding data, contributing data, sharing your observations, or analyzing data in an effort to help advance some area of scientific research or policy or decision making. And our whole theme of Science Saturdays last year, this year, hopefully moving forward, is to find ways to provide opportunities for everybody to act on things you're interested or curious or concerned about. So the topics that we learn about during Science Saturday, again, thank you, Jenna, and the whole team at Long Beach Island Foundation for making this possible. The topics that we talk about, we integrate citizen science, a way to act upon those topics that we're learning about. So, Dave, I'm going to let you take it from here. Introduce yourself,
Okay.
maybe a little bit of your connection to Jersey. If you have any that are directly related to Long Beach Island, all the better. And then talk about CoCoRaHS and maybe some of the trends that we're seeing, and then certainly how people can get involved. Thank you, Dave. And everybody else,
Terrific.
sorry, Dave, I just want to remind everybody if you have questions, you can either raise your hand using the one of the options at the bottom. On mine, it's called React. You can, there's a little hand raising there, and no problem, we'll call on you. And the other one is to just put your questions or comments there in chat. Thank you very much. Okay, Dave, thank you.
Okay, great. Thanks, Darlene. Yeah, this is a quick pulled together some slides for you um, from a number of various sources here. The fact is, just last weekend, um, I spoke at the Mosquito Control Association annual meeting at the Seaview in Galloway. Then that was Friday. Saturday, I did two sessions at the Pineland Short Course. So I hope no one was there because they're going to see some of the slides I did there. That was at Stockton. And then Monday, coincidentally, I was back to Seaview, where my wife and I spent the weekend because we didn't travel back and forth to Somerset County three times for the uh, climate and coastal resiliency conference. It was a 3-day meeting last week down there. So I've been down the shore. We did some hiking in Forsyth last Friday afternoon, and we were in the fog while everyone was in, and you probably folks were too on Sunday. Um, in the in Atlantic City when the rest of the state was beginning to enjoy what proved to be a very nice warm spell before it was back to a little bit of March crazy weather. I take it you can see the screen here, my slides?
All looks good.
Yeah,
Okay,
let's
great, great. Let me get going here. Um, who the heck am I? I'm Dave Robinson. I've been a professor at Rutgers for the last 38 years. And for 35 of them, in addition to teaching, doing global research, I'm a polar scientist when not playing the state climatologist. Um, so I've juggled a lot of balls here over the last 38 years, but for 35 years, I've been your state climatologist as well. And I'll tell you little bit about that. My background, I'm a Jersey guy. I was born and raised in Tenafly up in Bergen County. I spent multiple childhood summers on this place called Long Beach Island. Um, And before my family started doing camping and we went on the Outer Banks, and in my early married and life with kids, a lot of Cape Cod, but Long Beach Island is fondly recall that, including unfondly my some early childhood memories of being down there the summer after the 62 storm. So I'm dating myself and whatever, but these were my formative years with interest in weather and climate. And since then, college out in Pennsylvania, Dickinson College, started as a geologist, went to the Lamont Doherty Earth Observatory of Columbia University for grad school, and some time as a research scientist up there before heading down to Rutgers, where I've been ensconced for many years. But between you and me, not for very much longer. I'm retiring on July 1st. So you caught me at the last minute, although I still have like a half dozen talks arranged and such. So that's a little bit of my background, but it's Jersey roots here, and I'm pleased to have had the opportunity to do as a professional career what was an avocation from my childhood. I have records I kept of weather from a fourth grade assignment. And to be able to be paid to do this during my career has been a wonderful opportunity. And to do something I love, the earth sciences, has just been fabulous. But it's time to pass the torch on to someone else so I can enjoy the travels that my wife and I often do to really crazy spots in a way. I'm not teaching this academic year, so the first half of September we were in Greenland. We've done the geology tours of Great Britain, of the Alps, out in the Galapagos. We've done the volcanoes of Italy. We don't go to like Rome, what's that? Or London, what's that? We like to go. My wife was an earth science teacher for 35 years at the high school level and is adjuncted at Rutgers for a number of years. So we're looking forward to more of those adventures. Starting in July, when we'll be hiking up in the Pyrenees and in Andorra. So all sorts of fun things. So that's a little bit about me, enough about me. What about State Climate Office? We're here to help people make decisions, inform you with data, information, and our expertise to help you make decisions from the public to the governor, Office of Emergency Management, agricultural communities, transportation, you name it. That's what's been so enjoyable about this applied climate career of mine. You get to learn something from everyone every time you're out there. The mosquito folks, I've learned more about that. They tell me how weather and climate change is affecting them in this day and age, health officials, and so on and so forth. State climate officers are here at the local, regional level. I know New Jersey from stem to stern, be it through our weather network or camping with Boy Scouts from High Point down to Wildwood Beach, and so on. And so it's this local side of things you get from your state climatologist working in with colleagues at regional climate centers and at the National Climate Center. So it's just a wonderful community out there to help people make, in some cases, life-defining decisions. In other cases, we provided data on the climate and weather of the Meadowlands in July for the governor's office, and wonder what that was used for. The campaign to get the World Cup and the World Cup finals at MetLife Stadium succeeded, and it's this obviously this June and July there'll be matches up there in the finals on July 19th. So a real satisfying thing. This is our website. We're in a major renovation of website, which is going to get out before I get out the door. Let me quickly add that the State Climate Office is actually going to expand with my retirement. This has been just a portion of my academic assignments, if you will. I convinced the dean there's to make a full-time extension state climate position. They've hired someone at the senior level. I can't say who that is yet because there's a tenure process going on, and this person is coming from outside Rutgers. But I can assure you, I actually met with him, and he met with some of my staff yesterday, and it's going to be a wonderful addition for a bigger and better commitment from Rutgers for a state climate office. So I almost told the dean I was going to apply for the position when I heard what it was turning into. So I'm really excited about the future of the state climate office. Um, let's quickly go through the climate system. I'll give you some overview on Jersey climate, back to past events, look to the future, and then we'll dive into this wonderful CoCoRaHS program. So I'm going to blast through a lot of slides here. I'd be happy to share my slides with anyone. My email, you'll see it again at the end of the presentation. Happy to share my slides. And this is being recorded, as I heard at the beginning as well. Um, Climate system, Climate 101 in one slide. It's a system, no beginning, no end, interaction between the lithosphere, the geologic side of things, hydrosphere, all things liquid water, vapor, and such in the oceans, on land, rivers, groundwater, and such. The biosphere, be it desert or rainforest or this flux along the coast, these marshlands, saltwater marshes, for instance. Um, the cryosphere, something near and dear to me. As I mentioned, I study snow cover globally and have done some work with sea ice and ice sheets as well. Thus the thrill of being in Greenland and actually getting out onto the periphery of the ice sheet for a little time with one of my Rutgers colleagues who was up there on a sabbatical, and we joined her on the ice sheet. And the atmosphere, of course, with the pollutants in the atmosphere, with the water in the atmosphere, with beautiful fresh air sometimes in the atmosphere, and so on. All of this powered by the sun. Oh, but I forgot one thing. Look what's in the middle of this figure. It's us. It's what we're now having an influential impact on the climate system through our combustion of fossil fuels, our deforestation of various forests around the world, grasslands going to pasture land and cropland, so on and so forth. So there is a human component now that is part of this climate system. What about Jersey? As I said, I'm going to zip through things. We have a variety of climate areas. I mentioned I was in the fog last Sunday afternoon on the boardwalk in Atlantic City where it was sunny inland and 20 degrees warmer. I'll show you a slide about that in a little bit. But here we have the maritime influences, which are so, I mean, like I need to tell you folks that it's going to take a while for spring to make it to you, but boy, it's going to take a lot for the cold of the fall and winter to make it to you at the end of the summer season. The Pinelands, much more variable, hot days, cold nights. The agricultural region, truck crop region in the Southwest, a little further inland, a little further south, lower elevations. The heading north, you got that tweener zone, the Piedmont area, where sometimes it behaves like the north, sometimes behaves more like the south, and it has urban influences throughout it, urban heat islands in locations, so micro climates, if you will. And then the northwest, where you've got your hills, your valleys, and very different type of weather than often found down along the coast, making up for a really interesting potpourri of conditions based on altitude, latitude, surface conditions, forested versus urban for extremes, and the land-water contrasts, which are so keenly seen in the coastal communities of New Jersey. Um, I love Jersey weather and climate because there's a variety of, we have four seasons. I love winter. I love snow. Sorry, but I wouldn't want it all year long. That's for darn sure. And then, of course, we can have extremes. We can have some serious extremes. And here are just some examples. Sandy in the top left up at Manalocan. Fire, I'll get back to that a little bit in the Pinelands. Of course, the snows. You can see the heavy snows there. I mean, we were hiking in the Forsyth up in the wooded area, the Forsyth Reserve last Friday, as I mentioned, and a lot of damage to pine trees and holly trees as we were walking 4 or 5 mile path through there. Ice storms, not too prevalent right along the coast, but elsewhere bring down trees and power lines. The lower right is a cornfield in early August. Tells you one thing, drought. I won't harp on drought here. Suffice to say, right now, the state is in a drought warning. The wettest part of the state right now, the one closest to normal right now, is right where you are along the Jersey coast. Elsewhere, particularly in the northwest part of the state, it's been much drier than normal. The reservoirs a week ago, 2 weeks ago, were 50% of capacity up in North Jersey when they should be close to 90% as we get into March and April. But they've risen to about 60% since I spoke a week ago, thanks to some heavier rain up north, some of which made it to the south. So hopefully we're climbing out of this, but 19 of the past 22 months have had below average precipitation in New Jersey. So we're not out of the woods yet. We snuck out of it with a wet May last year. Um, if we are wet right now and we get better with groundwater and reservoir levels, let's hope that's a sign it's going to continue for months ahead in a persistent fashion. Because last year we were teased and then we were right back into drought conditions again. The lower center is downtown Elizabeth, New Jersey, the night of Ida, September 1st, 2021, where 30 people drowned, several in basement apartment in Elizabeth. The rest, almost 30 people in cars are trying to leave their cars in a zone from Trenton up to Newark and Bergen County, where the heaviest 2 months worth of rain fell in 6 hours. Down by you folks, not so much, except over on the left of this picture, that's an EF3 tornado that struck Mullica Hills in Gloucester County that afternoon. So there was violent weather around the state, but fortunately, no deaths or injuries from that. The largest tornado in New Jersey since 1990. And New Jersey never had stronger than an EF3, or it used to be called F3 tornado. So we get our share of dangerous weather interspersed with all of our seasons. And I wanted to look at the coast. These are two uh, images from just this past year. On the left is Hurricane Erin. Didn't put a drop of rain on New Jersey. It was well off the coast, but it was a big storm, and the swells just came onshore and resulted in significant beach erosion in late August. And then a stalled nor'easter, early season nor'easter in mid-October for several days kept pushing tidal waters into the bays and into the bays and on to the beaches and into communities along the coast. Um, a baby version of a slide I'm going to show you in just a second. Um, Going back to hurricanes first, these pictures, if they were in color, you might have said were sandy, but they weren't. They're from the largest, most powerful hurricane to strike New Jersey in the 20th century. It was 6 years after the hurricane of 38 decimated eastern Long Island and southeast um, New England. But that sideswiped Jersey with some heavy rain. But 44 hurricane came closer to the Jersey shore and really, really pounded it. They didn't have names for storms there. They were made up, at least not women's names, which began in the early 50s and then transferred to women and men's names in 1978. So they were named, the Great Storm of this or the Storm of 44. But this was the largest. There was a bigger hurricane in 1826, way back, boy, I'm blanking now, 1824. That went from Cape May right up to Garden State Parkway, but no one was living along the coast then, except down in Cape May. But it decimated part. Philadelphia got hit hard. New York got hit. City got hit hard. That was probably a Category 1 or 2 hurricane upon landfall. I used to talk about that a lot because it showed that Jersey could be hit by such a strong storm. I haven't had to say much about that since Sandy, although Sandy was a different beast. But I didn't need to turn people's attention to the early 19th century to prove to them that the Jersey Shore can be devastated by storms. And the 44 storm just didn't stick as much with people. And then there's the nor'easter of 62, of March of 62. Again, a strong nor'easter. It stalled for several days. And what eventually happened was, the water can't come back out of the bays at, after high tide before the next high tide comes in with more water. And so LBI was essentially underwater. LBI was hit harder by this storm than Sandy. I think anybody of you folks can hear me out. Not that Sandy, and I'll show you a photo, didn't have its impact. Believe me, I know it did. But Sandy was a little worse up the shore. Really, LBI was kind of ground zero for the damage in the 62 storm. Again, not that other parts of the shore, Jersey Shore, didn't get hit. And you can see well, there's a kind of a infamous breach at Harvey Cedars, much akin to what happened up the coast at Manahawkin from Sandy. And then Sandy. Sandy was a unique hybrid storm. It was a hurricane up until several hours before landfall, but it was already morphing into a nor'easter of sorts. So you had what we call a warm core of the hurricane starting to be surrounded by a nor'easter, which is more of a mid-latitude storm. So it was this hybrid, kind of like the perfect storm that sank the boat Andrea Doria up in the North Atlantic back in the early 90s. That never made landfall, but it did really hit the coast, even down here, but especially in New England hard. But this made a strange left turn because it was blocked by high pressure to the north, as you can see in this image. And the clockwise motion wanted to push that storm towards the coast. And then you had what's called a trough coming in from the west, and that helped to both pull the storm onto shore and intensify it, that the nor'easter part of that storm. So it was kind of a unique hybrid, but a very powerful storm that dumped several feet of snow in the mountains of West Virginia, brought record high temperatures to Montreal, severe weather storms to Boston. It was a very unique storm for its strength, its construction, and its path. And of course, New Jersey, it made landfall as what we call a post-tropical cyclone the evening of October 29th, right on Brigantine, at Brigantine. So I could talk about this. I gave hundreds of interviews within weeks of this storm. And here's an aftermath down Holgate. One of my students, I don't know what Will's up to these days, but Will decided with a buddy to ride it out in a family home. They had 3 feet of water on the first floor of the home, and there wasn't a second floor. And they almost went up on the roof, but then the waters came down. This is his buddy standing there the next day, and you can see some sign of the damage there at the southern end of the island. So, he said to me, Doc, I think next time I might evacuate. And I said, yeah, you think so? Fortunately, youth can be a little wacky sometimes, but thank goodness he escaped unharmed. Um, Here's some other damage up the shore a little bit at Ortley Beach. Houses just pushed inland. There's that break at Manahawkin. Um, and we shouldn't forget the people that lived on the mainland side who got flooded out from the waters of bays, Barnegat Bay in particular, here in Tuckerton. Now I'm going to quickly flip to fire because many of you have been conscious of that and seen the smoke from it, have not been threatened by the wildfires of the Pinelands, depending where you may have lived or ventured in the past. Smoke from the fire in the top left coming over the parkway. On the right is a picture of the Jones Road fire last April, which, for the grace of God, hopped the parkway and all, got near the closed nuclear plant, almost got into some communities. Would have been devastating in those communities, but the wind slackened. Conditions weren't 100% perfect for fire, even though it was dry. It wasn't as windy. The humidity wasn't as low as it could have been. Phew. I mean, that was a really close call and wonderful cooperation from the communities who evacuated when asked to, from firefighting officials, other emergency management folks. It was really a heroic effort on everyone's part to avoid tragedy. The lower center picture is a radar image of the smoke, the radar you look at for precipitation, and it was coming right across the island from there. I mentioned temperatures can vary in a short distance, and here you can see it's 56 degrees at Harvey Cedars, and you look inland to Sicklerville, it's 90 degrees. I mean, this is your classic. It can even be closer than that, 70 to the 80s, and so on and so forth. That's spring on the Jersey Shore, as you folks well know. We saw that multiple times just this past week. Well, I think one of the days it actually made it up into the upper, I think Harvey Cedars got up to 67 before the sea breeze kicked in. And now in the summer, of course, we all love that. Not only does it bring the cool air in, it pushes the bugs on shore. But the opposite at night, of course. The land cools faster than the waters, and you have a land breeze come offshore that pushes the mosquitoes. I don't know what it did. I'm 6'2", so it didn't stunt my growth. But I remember the old Army Jeeps putting fog out on the streets of Beach Haven while we were out there playing in the early evenings when I was a kid vacationing down there. But yeah, that was no doubt. Didn't know it was a land breeze at the time. Um, Anyway, quickly to climate change, because I have to talk about this. I've talked about it 1,000 times. I just have to talk about this. Climate's changing. Climate's changing globally. It's changing in New Jersey, and humans are responsible for a significant portion of recent changes. The last 40 or 50 years, you cannot explain the way the climate has behaved globally and in New Jersey without human activity. Observations show this change. Simple physics, greenhouse theory shows this, and models, sophisticated numerical models run on some of the world's fastest computers, are run up till today with no change in human impact on the climate, no influence of human on the climate, and then human influences introduced into this models. And the only way you can explain the changes we've seen in the last half century are when you bring the human influences into these models. So they tell us what's reasons for what's happened in the past, but probably the best part of the models are they're our crystal ball into the future. They're our way of adding more greenhouse gases, adding more of this, taking more of this away, and then running them into the future and see what they produce. So it's not just one thing. It's not just global warming. People said, oh, you climatologists started calling it climate change and not global warming. Look at my syllabi for the last 35 years. I was teaching courses in climate change. I never taught a class in global warming, maybe partially because I studied the impact of this warming climate on snow cover loss over northern hemisphere lands in the spring in particular, and how that loss of snow in turn helped to make things warmer. So it wasn't always about global warming, it was about broader issues of climate change. But let's turn to temperature. This is a time series, left side 1895, right side 2025. Um, and it's annual temperatures based on the averages of several dozen stations dispersed throughout the state over this 130, now 32 year period. Um, the blue line is what we call a regression line. It starts in 1980 onward. That's about when we, in retrospect, saw a human signal of climate change emerge from a signal that beforehand had human influences, but it was still dominated in some respects by natural climate variability. The climate variability we see in the past 2 weeks here, that wasn't all to do with humans, that was weather. But underlying all those weather changes was a human influence that made the warm days warmer and maybe the strong storms stronger. Um, yes, including a stronger snowstorm, which may sound a bit ironic. So you can see how rapidly New Jersey is warmed. Most years, not every year, it's very similar to global patterns you see. The last 3 years have been the warmest 3 years globally. Not here in New Jersey. 2012 was the warmest year so far in Jersey. You're going to say, but it was freezing cold this winter. And it was. But it was New Jersey's 36th coldest winter of the last 132 years. It wasn't the coldest winter. And believe it or not, for the contiguous US, the continental, lower continental US, it was the second warmest winter in 132 years. You're going, what the heck? Yeah, cold air was at a premium here in the eastern quarter of the country this winter. The rest of the country was baking. And just don't look at the forecast, but there's a huge heat wave going to develop in the next week over western US. It's horrible out there. They have very little snowpack, which they rely on for summer water. The heat's got to bring on air conditioning. It's got to get over 100 degrees down in Phoenix and Vegas and other areas, quite likely. So we experienced this cold winter locally, but even just for the US, let alone the rest of the world, it was for the most part a very warm winter. Alaska was really cold this winter too, but where we were in Greenland last September, they had a very mild winter by Greenland standards, 20, 30 degrees above normal throughout the bulk of the winter. But here, this is a sign that overall we are warming. We're getting a little wetter too, despite the fact you can see on the right side of the graph there, the last 2 years have been dry. But we had the two wettest years in over a century in 2012 and 2018. Overall, we're getting wetter, but notice the wiggles on the right side of the graph versus the left side of the graph. We're getting more variability in our rainfall. We go from dry periods to excessively wet periods. And those wet periods have very heavy rainfall events. When it rains, it pours. There's a warmer atmosphere, can hold more water vapor. And if you have a trigger to get that water produced as rain or snow, you can have very heavy events. If the trigger doesn't exist, the air's hotter, the seas are hotter, and things dry out faster on land. So you can go from drought to flood to flood to drought and so on and so forth. So a much streakier kind of climate system we're in right now. Very quickly, this greenhouse effect. You've heard about increasing carbon dioxide and methane from combustion of fossil fuels and from animal husbandry and rice cultivation puts a lot of methane into the atmosphere. But here's a quick way of thinking about it. The Earth has a natural blanket of these greenhouse gases that keeps the world habitable. Otherwise, we'd be an ice cube without an atmosphere based on the amount of sunshine that makes it to us. But it's like putting a blanket on the bed of natural water vapor, natural carbon dioxide, natural other gases. So what it does is it holds the sun's energy that comes through this blanket, holds it near the Earth's surface for a while. It eventually makes it back out to space. Just like under your blanket at night, you're producing the heat in this case, but the heat stays closer to your body for a while, but eventually it makes it up out into your bedroom. You don't self-combust overnight from that accumulated heat. But if you're still cold, put another blanket on the bed. And that's what humans are doing. We're putting another blanket on the atmosphere by increasing the greenhouse gases, carbon dioxide, methane. They in turn warm the atmosphere, and that allows more water vapor, which is the most ubiquitous greenhouse gas out there, to be in the atmosphere. So we are conducting an uncontrolled experiment, shall we say, in the atmosphere, but it's backed up by physics. You just simply can't put more of these gases in the atmosphere and expect it to stay as cool as it was. It's going to warm. And then I mentioned these models out there that are very sophisticated, include land and water and atmosphere and biota and so on. So, what's the future? Um, Steady or increasing precip for New Jersey. Dry areas getting drier, moist areas like ours getting wetter. Rising temperatures. You can take that one to the bank. Um, we'll talk about that a little more in a second. More variability, which I've already spoken to. More extremes of drought and flood and storms and heat. And then, of course, something know all you're interested in, rising sea level. First of all, temperature increases. On the left is where they've gone in Jersey. On the right are projections from climate models for the future. And you can see two colors there. The green is if we kind of control our emissions of greenhouse gases, burn cleaner energy, use less energy. That's the upward trend of temperatures, perhaps 5 degrees by the end of the century. The red is if we let things run amok as they currently are, and it could be as much as 10 degrees warmer. It may not sound like a lot, but averaged over a year, that's huge. Notice by the middle of the century, the colors don't diverge much. What we've already done is pretty much set for the trajectory for the coming several decades. But what we do now to control our use of these greenhouse gases is going to have an influence on the second half of the century. Um, this is a real noisy table. This is the latest report. It's the third edition of a report we've put out at Rutgers with some DEP and some other universities. You can see a cast of characters of us there on this. But I'll just bring you right to the middle of this. This is saying if we have control our emissions a little bit, and which we're doing slightly already. If we control our emissions, there's a 50% chance that by the year 2100, sea level will rise 2.9 feet above what it's been earlier this century, as recently as 10 years ago. So about a 3 foot rise. If we control emissions, it'll be closer to 2 feet. If we run amok, it will be over 3 feet. That's the 50% chance. There's chances it could be less. There's chances it could be a lot more. This would be a 17% chance closer to 4 feet by the end of the century. And these chances come in with ice sheet processes, whether ice lost on Antarctica or Greenland happens faster than some projections. It could run as much as 6 feet. Again, that's intermediate emissions. So that gives you a little bit of an idea where this is state of the art. This is state of the art modeling of sea level projections and along the Jersey coast for the remainder of early, late century, end of the century, and then even into the middle of the next century. I don't even want to think about this one. 20 feet is just, you know, enormous. And I'm not here to say that's going to happen. That's a low probability. It's a low probability and it's a long way away. So that's why I think it's more legitimate right now to look at these numbers in the multiple foot range by late century. We've already seen flooding more common along the coast. This is observations at Atlantic City, where there's been a tide gauge since the early part of the 20th century. This is a blow up of this part of the figure, showing you flooding number of days a year with flooding events. And you can see how it has increased in the last 40 to 50 years. These are projections based on intermediate emissions and low emissions. And you're talking about, by the end of the century, daily flooding. Every day, flooding the roads going into AC, the Back Bay commute portions of AC. Obviously, same thoughts up the coast at LBI. So we're already seeing more of this. A lot of this is sunny day flooding based on full moons, for instance, not all storm scenarios. And just because the water levels are already up a couple feet over the last century, and upwards of 6 to 12 inches just in the last couple of decades. And that's enough, as you folks know, that's enough to flood some of the lower lying roads and docks and so on when you get, even without a storm occurring. This is a model from looking from above what Seaside Heights would look like. With a 3 foot rise, this part of Seaside Heights would be permanently underwater. With a 6 foot rise, you know the scenario. You've heard this. I want to zip through this, just the impacts. I work with all these different communities. They're telling me what's happening as signs of climate change. I don't have to talk to them, but it helps to work together to understand what's going on out there. Um, a little preachiness. Thanks for listening in today. We all need to get a better understanding what's going on here. And then with greater unanimity, I've spent way too much of my career having to get people to understand what was going on and battle people who choose to ignore the science. With a common understanding, we can work together to mitigate and adapt. We're not going to be able to mitigate away from this, but the more mitigation we do, the less we're going to have to adapt. But let's face it, we're already having to adapt. And let's do it with two thoughts. One, adapting to better handle storms right now, like a Sandy repeat and other major storms. And in the process of doing that, that prepares us more for the more common sea level rise and impacts similar to a Sandy, but from a less impactful storm 20 years, 30 years from now. And then, of course, we need some leadership. We got to get out there. We got to exercise our vote. We have to be part of the community that on the local, national, and global scene. Okay, preachy slide over. Now let's talk how we're going to monitor this, because that was a thrust of today. First, I'll talk to you about a weather network we have out there that hopefully, some of you may know about. We have something called the Rutgers, New Jersey Weather Network. This is something I've developed with my small group of colleagues over the last several decades. It now has 70 stations from High Point Monument to West Cape May, including Harvey Cedars, where we gather data of multiple weather variables every 5 minutes via modem and we make them immediately available to the public. This is Atlantic City Marina page. I'll show you another in a minute. We have maps every 5 minutes. We have as individual web pages for each station in our network, and so on and so forth. This gives you a rough idea where the stations are. It doesn't include all 70 on it because some are so close together they kind of overlap. But it gives you an idea of the distribution of these stations. This is the Harvey Cedar station. Just an hour and a half ago, 2 hours ago, I grabbed this. Wonderful cooperation from the Office of Emergency Management and Harvey Cedars. We have a long-standing good relationship with these folks. This is kind of a unique station. Most of our stations are situated on the ground, and wind is measured at about 10 feet off the ground or 30 feet off the ground on towers. Here, LBI, it's tough to find a place to put a station like that. It's on the roof of the Harvey Cedars Municipal Complex there. And you can see temperatures measured there. You can't see the rain gauge there, automated rain gauge and an anemometer. I'm very pleased to announce we have two levels of stations, one that have more sophisticated data loggers and a little bit different anemometer to measure the wind. We are upgrading this station this spring to one of our top-notch recording stations. If we lose contact with this station, the data logger can hold the data for a longer period of time than the current data logger at this station. This has been, yes, it's rooftop, but at Harvey Cedars, the wind's blowing, it's near the bay, it's near the water. It's almost a buoy out there. Another story about this station. In Sandy, we had about 50 stations by 2012 for Sandy. We lost one. We had one problem with one station. This little mast here blew over. It's our only station that had damage out of 50, including stations at Seaside Height and Seagirt and Point Pleasant, West Cape May, Atlantic City Marina. But that was the one darn, and we didn't get the peak wind. The 91, I think we measured at Seaside Heights. But still, this has been a really terrific station, and again, every 5 minutes we update it. A lot of variables. Let's zip through this. Go to the next one. Let's talk CoCoRaHS. Now we'll talk about something in the citizen science realm that you can become involved with. This is one of the nation's top citizen science programs because it's got over 25,000 observers. It's something where you can participate on a daily basis. There's other wonderful citizen science networks, don't get me wrong, phenology networks and some on wildlife and astronomy and so on and so forth. But this is one where you can do it on a daily basis. You get yourself a rain gauge. This is the standard rain gauge we ask people to get. It's about, with shipping, it's under $50. I call it a cheap hobby. And you get a ruler to measure snow. You go out once a day if you can. If you're away, you don't do it. If it's icy in the winter and you don't want to go out, you don't do it. But you can go out once a day in the morning, we ask, 6 to 8 a.m. You take your observations and then you get online on an app on your cell phone or on your computer and you enter your data and it immediately goes into a national database. It's so respected, this network. These data are archived at the National Centers for Environmental Information, Mecca, the global Mecca for climate data, sitting down in Asheville, North Carolina. And we do quality control in New Jersey, and there's a national quality control as well. This is a national program. It's in Canada and the Bahamas as well. Started in Colorado State after a big flood in 1997. They wanted to know just how much rain really fell from events like this. We don't have enough rain gauges out there. So they instituted this program. It went to Colorado, it went to the High Plains, then it spread nationwide. We started in 2008 in Jersey, um, on February 2nd, 2008. And everyone here should know why I chose February 2nd, not February 1st, to start the program. Think about it. CoCoRaHS.org. This is a page you'll see where you can go in. There's a lot to plow through here. There's tutorials. There's information about how you can get the rain gauge here from private companies. Tutorials, cartoons, PowerPoints, videos. So there's all kinds of training. Um, and myself and Matt Gerbush, the assistant state climatologist, managed the New Jersey CoCoRaHS program. We have some coordinators in counties that help us out communicating with our observers. And it's kind of neat. You can find out what your neighbor might have measured for rain, or you can find out what fell out in California or up in Alaska on a given day. So you can keep it local or you can go broader than that. Um, so what is it? Again, grassroots, nonprofit, community-based, high density. I mean, we have 70 weather stations um, measuring every 5 minutes in an automated fashion. We have over 300 active CoCoRaHS observers, and on a rainy day statewide, we'll get about 270 reports. Immeasurably helpful, as we'll mention in just a minute with a slide. Anyone can do it. We've had families with kids in elementary school and octogenarians, all ages out there measuring in your backyard. Um, this gives you an idea of what a map looks like with the number of CoCoRaHS observers in the mid-Atlantic on a particular event. Um, it's always 7 a.m. to roughly 7 a.m. the next day, and it's color coded by how much fell. We get a number of our observers go out over a couple hundred, 200 sometimes in a snow event. Some people just aren't comfortable going out in the snow and the ice. So we say, take the winter off, come back in the spring, or whatever. Or on a day where it didn't precipitate, the thing is, be a hero, report your zeros. I didn't make this up. But the idea is we need to know when it doesn't precipitate. Right now, it's been very helpful in monitoring the drought in New Jersey by knowing when it doesn't rain. I know let's face it, on a daily basis, when it doesn't rain, we get maybe 200, 180 to 200 observations. On a day when it rains, all of a sudden we have 260, 270 observations. Some people only measure when it rains. Others will do it on a daily basis. About 130 observers miss fewer than 7 days in a year, every year. But we've registered something like 700, 800 observers since 2008, and only 300 plus are still active. A third of people who register never take an observation. A third of people who register hang on for a year or two. And then about a third hang on for multiple years, in some cases over a decade. It's just the nature of volunteerism. We get it. People move away, people pass away, kids graduate from high school and go off to college. It happens. But the snow observations are so helpful. Most of the observations in New Jersey from the snowstorm a couple weeks ago were from CoCoRaHS observers because we have good, smart observers and we help train them. Matt will write emails to people. How'd you measure snow? How often did you measure snow? Where did you measure the snow? Because your numbers don't look quite right. And sometimes it's an education process. But this was the snow totals. And some of these are from Weather Service office observers who call in, but they're usually much less reliable observers. And you can just see the heaviest of snows from this last storm. And the fact is, the northwest part of the state had the least amount of snow, under 10 inches. whereas upwards of 2 feet fell here. But we saw reports coming in from the Weather Service of 30 plus inches, and it didn't happen, folks. It didn't happen. We have CoCoRaHS observers, well trained, know how to measure snow, and they confirmed the fact that some of the reports that came in through public media were, for whatever reason, they measured it in a drift. They wanted to get attention to themselves. I don't know. But CoCoRaHS observers are fantastic. This shows you this morning, up until 9:30, the number of observers in Ocean County who entered data. There'll be some who won't enter till tonight. It didn't rain yesterday. I guess there was some early morning rain from the day before. A couple of communities, Surf City had a 10th. Um, and it's a Saturday morning. But this shows you already by 9:30 this morning, these wonderful people. Some of maybe a couple of you, I don't know. There, we'll show you LBI in a moment. I am in awe every day when I look at this. Just in awe that people take the time to contribute, become a community contributor to this program. This shows you how many from Ocean County observed in the last 365 days as of this morning. And it's in alphabetical order on the left, so you can look for your communities. And you see two in Surf City, but this is based on the number of observations of those people on the right. So we hadn't had someone with 365 days in all, but you see Point Pleasant, Lacey, Stafford, Little Egg Harbor, but Barnegat Light, very common observer, and Surf. We've had two Surf City observers who, over 300 observations in the last year. And sometimes they'll put in, if they're away for a week, they'll put in a multi-day observation, which counts as one observation, but it would cover a 7-day period while they were away. But other times people go away. So that's why we need the community to do this, so we can get an idea of what's going on. Here are observations from yesterday morning, because it had rained. That's why I picked this out. And you can see Barnegat Light, Surf City, and then you're on to the mainland. We have someone down in Brigantine who contributes and down in Ocean City. But this shows you up and down the coast. This tells you we need more Long Beach Island observers. And we could go down the island. Well, you can never have enough CoCoRaHS observers. There was an elementary school in Surf City. I don't know if it was right in Surf City. I spoke to about 8, 9 years ago. I went and visited them, and they had a rain gauge, and they were observing for a while. I don't think that's the Surf City. I don't know. I'd have to look at their metadata, the information about these stations, but we could always use more observers. As I meant, I'm going to zip through these. There's training, there's your rain gauge, a lot of information on how to best measure snow. You can see a station set up here with a snowboard to measure your snow and the rain gauge on a pole, a little bit off the ground. You want it in an area where if you open your arms and do a full circle, you have nothing above you, tree limbs, the eaves of your house or whatever. But it doesn't have to be a whole open yard. Um, but rooftops tend to be very windy and that blows. There, an aerodynamic dome forms over your rain gauge and it gives you an undercatch of precip. So whatever. And by the way, before I forget, if you have any interest in this and any questions, email, and we'll answer them. I say we, myself, and Matt Gerbush, are our two leads. You've already seen this. Now, why CoCoRaHS? Well, we know how variable precip is. We need information on this from as many sources as possible. It's important to collect hail if you can. Jersey's not a big hail state, nor is the coast of Jersey. but storm reports are very important. Look at all the people who use this. I mean, I won't hold it on long, but this isn't just for fun. It's fun, and it's fun to compare, and you can be a weather weenie and compare things. But it's more than that. This is really useful information from the Weather Service, from DEP's Water Resource Group, the agricultural community, and insurance purposes, scientists who want to understand things. There's your mosquito mention. Um, all you need is to complete an application form. It's online, CoCoRaHS.org. Um, and then you want to learn how to take legitimate measurements, and we need to know your location. And we'll work with you in the national office as well to make sure we get your right community, your right precision to where your station is located. And then from there, whoops, um, what you'll need, the desire, of course, get yourself some training. Um, you'll get your unique station. You saw those things with NJ-OC dash a number, which will be assigned. I'm NCSM 92. I'm the 92nd person in Somerset County to register. That's because I moved, because I used to be SM1, but then I moved. So I got assigned a new number because it was a new station. Um, you need that gauge. No automated gauges, no um, hardware store little gauges. This is a really accurate gauge. You can see there's an inner cylinder and an outer cylinder, and I'm not going to explain it here now. But that inner cylinder and source, when it fills up, that's an inch of rain because it funnels in from a much larger area. And if that inner cylinder fills up, it spills with a notch into the outer cylinder, and that fills. And then you have to fill that inner cylinder to measure your rain carefully. Enough of that. Then you go in and you enter your data on your cell phone or your computer. Do you have to participate every day? I already said no. How long is your commitment? As long as you want the commitment to be. So that's quickly CoCoRaHS. Now let's step back, and I'm sorry I've taken so darn long, but thank you for holding on and hope that you found this interesting. Great weather in New Jersey, all types. My screens are rattling right now because it's pretty darn windy looking out to the west here out of my second floor study. Um, but it's awfully clear. Climate's changing in New Jersey. We still have weather, we still have day-to-day variability. We're seeing more extremes. We're already seeing that. And this change is going to continue and it's going to accelerate. And we're going to see more extremes. That includes sea level is rising. It's projected to rise at a faster rate in the future. Temperatures rise at a faster rate. More extremes. With that, there'll be more impacts. And you folks know that. You folks are well aware of that. And then back to the observing side, what you do and what we do with our weather network and look to the future, keep a watchful eye. But I don't want to leave you totally depressed. Don't go sell your house, your shore house now, but you guys know how to be better prepared along the coast. And the fact is, we got ourselves into this mess because we're so innovative. We developed the combustion engine, we started burning fossil fuels, yada, 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 yada. I'd like to think there's smart people, maybe our kids and our grandkids out there, that are going to help us come up with creative, mitigative, and adaptive approaches to dealing with this. So I don't want to leave people totally depressed. The sky is falling, the sea is going to inundate us. But we better be aware of this. We better understand this because to ignore it is to put ourselves in short-term peril from extreme storms and long-term peril to the Jersey Shore, which is the lifeblood of Jersey. It's the culture of New Jersey. So with that, I'll stick on as long as you have questions. But I understand some of you may have to run.
That was
So thanks,
great.
thanks very much.
Thank you, Dave. That was extremely informative. Thank you. And anybody who has questions, please put them in the chat. I see one from Jill. You've heard him speak before, always an excellent speaker. He will be missed once you retire, but maybe we'll still have you back. Maybe you're still willing to do the speaking circuit. And thank you, Jill.
Um, I, I have, believe it or not, I can't do anything for 120 days
Okay.
because it's the state university. They can't tell me what would happen if I did something because I don't get a pension. Rutgers professors are not pensioned. We're 401ks. My wife retired from teaching. She couldn't adjunct at Rutgers or be our education component for 120 days, or she could have lost her pension.
Okay.
And I also have to let the new state climate. I'm the longest serving state climatologist in U.S. history, not
Oh
just
my
now.
gosh.
So I have to step back and let my successor and others, assume an identity. But yeah, I'll be around.
Okay. That's what we like to hear.
I'll be back.
Back at day 121. We know where to find you too. I'm very curious because this summer we're looking to help equip people and mobilize them all around the island to get involved in citizen science, putting some of the CoCoRaHS rain gauges in some of the community gardens, the pollinator gardens, and
Mhm.
to make it easy for people to share their observations. Real simple signage to like, this is registered. If you see precipitation in here, document it, dump it out, put it back. To the extent that we can, we'll have kind of shepherds there. I think it would be very helpful if you're able to help put us in touch with the people in LBI who are already involved, because I think we can really learn from their experiences too, if they're comfortable with it. That was one question I had.
Okay.
Other is for anybody on the tuning in right now or watching the video, if Dave gave just amazing information. If you still have questions and you're not, you really don't want to lay out the whatever it is, $35, $40 for the rain gauge. Also let us know, because we are able to help support in some ways. This is not LBIF, this is now SciStarter, can help support you getting a rain gauge. You just have to kind of commit to doing the project, but you see all the reasons why that's important. And it is a fairly simple project to set up.
Oh yeah.
It's
Yeah, it is. But I believe it or not, and you know this through your work with citizen science, they did a study where they gave people rain gauges and had people buy rain gauges. And who are the more active participants?
Let's get in the game.
The people, yeah, the people who committed to it. It's just
Yeah.
the way it is. We've never had the resources. You might think, oh, it's Rutgers or whatever. No, we
Yep.
don't get anything special for operating the CoCoRaHS program in the state. So
Yeah.
we've never been able to
Give away
distribute
the
them.
basics. That's okay. I think we'll have a committee. This group here that tunes into Science Saturday, they're phenomenal.
Yeah,
It's
I
nice when
bet.
we get
Yeah.
to be in person too, which we will again at the Long Beach Island Foundation in Love Ladies. That was so eye-opening to me. Some of them are on the line now to hear the stories of what happens after these calls. I learned from one where we did a similar program, and they learned about rain barrels. And when I met
Mhm.
this couple in person, it turned out that not only did he make all these rain barrels, but he made them for his neighbors too. So he got his street and Surf City involved in really
That's
good.
great.
We have a question here from Jeff, which is who measures beach erosion and impact of storms and high tides on dune height?
Yeah, that's DEP, Department of Environmental Protection, absolutely is involved with this. There's also been a long-standing program at Stockton University. The originator of that has retired, but is still being done. Don't quote me on all the details there, but Stockton has done a wonderful beach measurement effort. There might be some coming out of Monmouth University. There's one of my previous colleagues who's long retired now, but still interested in this, Norb Sudi at Rutgers, was known as the coastal geomorphologist for New Jersey. But there wasn't a real active continuous measurement program through Rutgers. Stockton would be the one. And then local communities, no doubt. And then I fail to say, folks know, U.S. Army Corps of Engineers is involved with beach replenishment efforts, which involve coastal measurements too. Corps of Engineers nationally, DEP statewide, Stockton University from the academic studies side would be my three go-tos.
Great. Thank you. Any other? And Jeff says thank you. Okay. Jill, is it too early to predict if we should expect future winters to be like the one we had this year with there's some snow versus the more mild winters we've had at the Jersey Shore area during the past years?
Yeah, I mean, as I mentioned, it was 36 coldest winter. It was the coldest winter since the winter of 2013-14, as I recall, with all the numbers going through my head. So it's been unusual. And the last two winters have all had all 3 months, December, January, and February, have been below normal for temperature. That's all the rest of the months have been above. Um, the way you look at this, I mentioned weather and climate. Think of in the past, you had a dice and you broke the seasons, the winters and cold winters, intermediate winters, and warm winters. So your dice had two W's, two colds, and two I's on it. And you rolled it, and sometimes you could roll two or three C's in a row or W's in a row. What we've done now is we've loaded the dice, taken one of those C's away and added a W instead. So when you roll the dice, you have 50% chance of being above normal, 2 out of 6 chance of being intermediate, and 1 out of 6, but still 1 out of 6 that it could be colder. No one's saying that every year is going to be warmer. Every season is going to be warmer. So we expect, and we've already seen that we have fewer cold winters, but it doesn't mean we can't still have a cold winter. Witness what we just went through.
That's a great way to put it. The probability. Jill, I hope that answered your question. Joe says thank you. And last call for any questions before we say thank you and goodbye to Dave and happy retirement. And we know that we're going to have you back. We're so glad we got our claws into you. Jill said thank you and thanks for an excellent presentation. It really was fantastic.
Thank you. I love to talk to any group, as you can tell. And yes, I would be happy. I'm not going to disappear, but
Good.
just lay a little lower.
Yes. Well done, Dave. Pleasure listening to you. So all great stuff, Dave. Thank you so much for
Thank you.
everybody. If you can get involved in CoCoRaHS, just start by going to the website. You can find it on the LBIF website for Science Saturday. You'll see that we have a CoCoRaHS link to that, or just CoCoRaHS. And in fact, Jenna, sorry. If we can email everybody who registered with a link to the recording, we can also email the link directly to CoCoRaHS. So let's do it. And then Dave, I'll circle back a little bit if there's a way to connect with the people on LBI already involved.
Yeah, I've written a note. I'll talk to Matt, and we've done this for media, for instance. By the way, I'm always interviewed by someone from the Sandpiper down there.
Oh, good. Great.
So he's got me on speed dial. And he's always looking for LBI reports. So you'll get yourself in the news.
Yes.
But we will contact observers and see if they're willing to. Some don't want to.
Yes, definitely. We respect their privacy.
Yeah.
Isn't there a March, or now it's been moved to April, but there is a push in April. You want to tell us a little bit about that?
Yeah. I'll tell you what, while they do that, I forgot, I didn't go to the last slide. And I want you to see that because it's got a nice picture of LBI, but here's my contact information for anyone needs it. Yeah, it used to be called March Madness, and they were afraid that the NCAA was going to sue CoCoRaHS Central. Tried a different name last year, a couple years ago. Anyway, let me quickly unshare again. Doing scroll this. Stop sharing. There we go. And now it's a recruiting month. To tell you the honest truth, we've never done much with that because I'm in the middle of a semester. And my spring semester, I've always taught 2 courses, one with 300 students and a smaller students. We haven't invested in the March recruitment program. Um, Maybe they'll decide, my successor will decide to do so. But it's April, and it's a time to get out there. You know, they give two awards: the state that signs the most new observers, and the state that population proportionate signs the most. And we can't begin to compete. It's unbelievable what Minnesota does. They have a public radio network where they get people in and such. So we just anytime we have a chance year round, we want to sign people up.
Okay, let's
So
hope they win.
yeah,
Up in
you're
April.
you're not going to because we have 9.5 million people. But if you look at the CoCoRaHS map, folks, you'll see we're a densely popular, we're a densely populated state. We're densely packed with CoCoRaHS observers. We could use more right along the coast, as you saw, Cumberland and Salem County on the low end. Inland, Atlantic and Cape May, Ocean, and Monmouth are great, and so on and so forth. We
Mhm.
could use a few more in urban areas, although we have them in every county of the state. But it's kind of the rural ag area. Of course, the middle of the Pinelands. Um, we can't get the Jersey Devil to make observation out there. Um, but we can always use more. And so we're always interested because people come and people go. So,
Yes. Well, and
but
tying to the recruitment effort in April, it is also, this team knows, Citizen Science Month with their big collective goal of 2.50 million acts of science. Let this be your act of science in April, the celebration of America's birthday. All that is happening in April. So
there
let's do
you
it.
go.
Yep.
Yep. And please contact us for any more information. We'll get back to you too, darling.
All right. That sounds great. Thanks, Dave. Thanks so much. Bye, everybody. Have a great week.
Bye,
Thank you.
everyone.
Bye.
Thank you, Darlene. Thank you so much, Dave. Have a fantastic weekend, everyone.
Same to you.